And all right, I'll start reading out the answers. You got this. I have the textbooks out open also, so that once I get through the answers, we can go right to review anything that you guys need. Okay, so what do we have? We have number 6 is -3. 10 is 34 times 100 centimeters. 12 is 9 centimeters. 13 is 14 pi meters. 14 is -11. 15 is -17. 16 is 4. 17 is -1. 18 is 0. 19 is -5. 20 is -20. 21 is -3. 22 is -12. 25 is -7. 27 is 50 plus 5 pi kilometers. 28 is 65. And 29 is 4. Anyone need me to repeat any answers?
I got a few questions.
Okay, but any answers anyone needs repeated? One other thing that I'll just note is if there's anything that you want, if you ever think that you need more practice, you can always go ahead and do all the problems in the set or some of the additional ones. And then if you have questions about them, please come, feel free to come and ask me about them. Or we can even go over them in class. All right, so yes, you had a couple that you wanted to go over from here. So please have your textbooks open to page 32, 33, so we can have these problems in front of us. Which one would you like to start with?
Number 12.
Number 12, the perimeter of a square is 36 centimeters. What is the length of one side of the square? All right, so you draw a picture. We know we've got a square.
Oh, that's what I drew wrong. Never mind.
Okay, you got it? So all 4 sides are the same length.
Yeah.
If the perimeter is 36, then each side is 9.
I forgot that.
It wasn't. I didn't do the perimeter. I thought
That 9 times 4 is 36. So I can find the number.
Yep.
You need 29.
29. Was that on the list?
Yeah.
Yeah, okay. 29. Simplify. 21 over 5
Oh, yeah, I got this one too.
times 15 over 7 times 4 over 9. Okay, so what are we doing in this problem?
Multiplication.
Multiplication of
This is
Numbers. Fractions.
fractions, right. So simplify can mean a whole lot of things. Simplify just in general means put this into something that's easier for us to work with. In this particular case, simplifying these 3 fractions multiplying together is going to mean combining them. Usually simplifying is going to mean combining, putting things into an easier format to deal with. If we're doing a big long equation, if this is one of the things going on in there, we say, wait a minute, these are 3 fractions being multiplied together. This is something that I know how to combine. So we're going to multiply these 3 fractions together. What can we do here to make our lives maybe a little bit easier? Yes?
you can divide, like you can take 5, maybe change it to a 1, make 15 3.
Right, so notice we can cancel things out. There's 5 on the bottom, there's 15 on the top. Because things on the bottom, that means divide by that. So we can, these are each divisible by 5. We divide 5 by 5, we get 1. We divide 15 by 5, we get 3. All right. Is there any other simplification that we can do?
7.
7.
The 7 and the 21. So what are they both going to, what are they each going to become? 3
That's
and
gonna become 3, and that's gonna become
1. Is there anything else that we can do? Yep.
3 and the 9.
The 3 and the 9.
Wait.
Oh, it's gonna become 3 and 1.
So the 3 will become 1, and the 9 will become
3.
3. We divide them both by 3. Now what we have, instead of these big complicated fractions, and if we tried to multiply all those numbers together, we would end up with some really awkward fraction to deal with. But by canceling out, look, on the top, we have 1 times 3 times 4, which is what? Or actually, we can go another step further.
You can use 3.
We can do the 3 and the 3, and they each become 1. So we've got 1 times 4 on the top, and on the bottom, we've got 1 times 1. And instead of writing 4 over 1, what's an easier way to write that?
4.
4. There you go. There's your answer, simplified all the way.
Wow.
When you've got fractions like this, before you multiply them together, ask yourself, is there anything that I can cancel out? And if you can at least cancel out some of the things, then you'll end up with something easier to deal with. Maybe you weren't able to find all the things that you canceled out here and you ended up with 12 over 3, for example. Well, that's fine. You can take 12 over 3 and then simplify that to 4. It doesn't matter the order that you do these things in, but the more that you can do before you do all that multiplication, the easier that you're going to make it for yourself. Next one that someone wants to go over. Yep. Guys who are watching the live stream, you can also write in with ones that you want to go over.
20.
20. All right. So in 20, now let's make sure we write it out correctly. We've got negative 4 minus 3 plus 2 minus 4 minus 3 minus 8. Did I copy that correctly? Minus 3 plus 2 minus 4 minus 3 minus 8. Okay, now, what do the directions say? Use parentheses to enclose each number and its sign, then insert plus signs between the parentheses, then add to get a sum. So what are they telling us to do here, effectively? Add parentheses, okay. So, how are we going to rewrite this?
Parentheses, negative 4 minus 3 plus parentheses 2 minus 4 parentheses plus negative 3 minus 8. Right?
4, 3. So they say each number is going to be enclosed with its sign. And how are all these numbers being combined together? How are they being combined here?
Negative.
Addition. So what we've effectively done here, their explanation for this is a little complicated. What we've effectively done is we've taken all the subtraction and we've changed it into addition. So negative 4, fine, negative 4. But instead of saying minus 3, we're going to say negative 4 plus negative 3. That's the same as saying minus 3. Plus negative 3 is the same as saying minus 3. And the advantage of changing it into addition is what? Two
You don't have
advantages.
to change thing. You don't have to switch around. You can just add it like that.
Yeah, we can just, so here we're going to end up with two negatives we can add together. Also, adding is generally easier than subtracting. And what's the other big advantage of addition? What order do we have to do addition in?
You don't.
Any order we like. There's no specific order. Whereas subtraction, the order matters. 4 minus 2 is very different from 2 minus 4. So now that it's addition, we've got some negative numbers and some positive numbers that we're adding together. What can we do here? We're combining negative and positive numbers together with addition.
Negative number.
Well, yeah, it is going to be a negative number here. But so, how should we go about adding these all together?
Let's do 2 at a time.
We can do 2 at a time. All right, so what's negative 4, negative 3?
Negative 7.
Negative 7. All right, what's positive 2 and negative 4? Negative 2. And what's negative 3, negative 8?
Negative 11.
Negative 11. All right. So what do we get? Negative 7 plus negative 2 is?
Negative 20.
Yeah, this is negative 9 plus negative 11 is negative 20. So we could take these, we could combine them by adding in groups of 2. We could also have done it by adding together all the negatives, and we would have gotten negative 22 plus 2, and we still would have gotten negative 20. The order doesn't matter. You can do whatever's order is convenient for you. Questions about this or another problem?
Number 22.
22. All right. So same kind of problem here. We've got negative 7 plus negative 8 plus 3. Writing negative 7 with no parentheses around it and negative 8 with parentheses around it, that's the same. The parentheses there don't do anything except that remind us that the negative is attached to that number. It doesn't matter if we write negative 7 like this or if we put parentheses around it. The parentheses can help us remember that the number we're dealing with is negative 7 as opposed to just 7. We don't actually need that there. So we could write that in there. To solve this one, what will we do?
7 plus 7. Negative 7 plus 7.
Negative 7 plus negative
8.
8 is what?
Negative 15.
Negative 15 plus 3 is
Negative 12.
negative 12. There you go. Any others?
But for number 27, I did I multiplied the
7. We've got this shape here. What is it? 20, 10. And this radius here is 5. So we've got 20, 10, and then 20. So these three sides add up to 50. Now we need this curved part here. What's the length of that curved part?
10.
Not 10.
The length.
The length of this curved part here to go all the way around.
Oh, 15.
Yeah. So how do we get that? What kind of a thing do we have here?
10 times 3.14.
Right. So we have 5. So the circumference of the whole circle is 10 pi, but we don't have the whole circle. What do we have? We have half the circle. So what's this here? Not 10 pi, but 5 pi. 5 times pi. 10 times pi. Half of that is 5 times pi. So we've got 20, 10, 20, so a total of 50. And then we've got 5 pi. And how are we combining those two together?
Oh, 25 pi. 55 pi.
Be careful, because this is 50 times 1. 5 pi is a different kind of thing. We can't add those together.
Also 30.
That's like saying 50 apples and 5 bananas. Yeah, you can't turn that into 55 bananas. It's just a different type of thing. It's apples and oranges.
Banana.
What?
Banana.
Banana apples. Yeah.
Open an apple.
So if we wanted to, we could convert this into apples, so to speak, by multiplying 5 times 3.14. Right? We'd get whatever it was, 15.7 or so.
Oh, no.
Then we could add them together and get 65.7 or so. But if we leave pi in there, we can't combine it with this. Because this is a different sort of thing. This means 5 times this quantity pi that I don't want to deal with right now. Whereas the 50 means 50 ones. And what's our unit for that problem? Anyone?
A centimeter, kilos.
Kilometers, yeah. All right. Last call. Any problems? Guys watching the live stream, go ahead right in if you want to go over one. Last call for problems from this problem set. Problem set 7 is short. Lesson 7 is short, so we're going to go over that pretty quickly, and then you'll have lots of time to work on the homework.
Okay.
What do we do with the homework? Like, I have a bunch of things I want. Like, do you want us to keep them or why?
You can do what you like with them. You don't need to retain them. Once I've checked them, you don't need them. All right, open your textbooks to page 34. Page 34. Can I erase all this up here?
Mm-hmm.
If I can't, well, I guess you can go back and watch the live stream and find it there. It'll be preserved forever on the interwebs, just like all of your poor adolescent decisions will be preserved forever on Instagram or TikTok or whatever it is that the young people are using these days. What?
Everything you just listed.
Everything.
Like 20?
20, what, how, 28, yeah.
That's pretty young.
Yeah, I know.
Wait, and don't feel like you.
Yep, number 3 is on the way. It's a boy, by the way.
Only 14 years old. My sister's
I have 2 daughters, and then I've got a boy on the way.
And you're 28, that's enough.
Yep. All right. All right, so, okay, 34. We talked about the concept of the opposite of a number, opposite numbers. What do we mean when we talk about opposite numbers?
Opposite of a positive number, or opposite of a negative number.
Yeah, so what's the opposite of positive 5, for example?
Negative 2, negative 5.
Negative 5. What's the opposite of negative 13? Positive 13. So opposite numbers, we can say have the same absolute value, but they're on opposite sides of 0. So absolute value, remember, means the distance from 0 on our number line. So negative 5 and positive 5 are the same distance from 0. Going from negative 5 to 0 is the same distance as going from 0 to 5. But they're on opposite sides of 0. That's why we call them opposite numbers. Another way to think of the negative sign is we can think of it as meaning the opposite of. So when I say negative 5, I mean the opposite of 5. The thing that's the same, that has the same absolute value, but is on the other side of 0 from 5. Yes? Make sense so far?
Mm-hmm.
Okay. What this means is that when we talk about the opposite of a negative number, we know we're going to get a what? A positive. So if 5 is 5, negative 5 is the opposite of 5. What about negative 5? It's the opposite of 5. So what's that equal to? Negative 5. So we have 5.
Mm-hmm.
Then we have the opposite of 5 is over here. What's the opposite of that? 5.
Wait a minute.
Yeah, because 2 negatives.
Right. 2 negatives make a positive. The opposite of 5.
Wait, so you're basically just multiplying negative 5 times negative 1.
Yes.
Okay.
That's the other way to think of the negative sign. The other way to think of the negative sign is it means times negative 1. So this means 5. This means negative 1 times 5. This means negative 1 times negative 1 times 5. And negative 1 times negative 1 gives us
Negative 1.
negative 1 times negative 1 gives us
Positive 1.
positive 1 times 5 gives us 5. Right. You're right. So there are a couple of different ways we can think of the negative sign. We can think of it as meaning numbers to the left of 0 on the number line. We can think of it as meaning the opposite of this here.
But if it's 3,
Yep.
if it's 3, that means it's, like, say it's negative 2. So I'm looking at one of these. It's like negative 2, and there's like 3 of them.
Like this?
So it's going to be negative 2, and then it's going to be 2, because that's the opposite of it, and it's going to go back to negative 2.
Right. So this will be negative 2 because we know what negative 2 is. The opposite of that is 2, and the opposite of that, again, is negative 2. So we can count the number of negative signs. And if there are an odd number of negative signs, so if there's 1 negative sign, if there's 3 or there's 5, then is the whole thing going to be negative or positive? If there are 1, 3, 5, 7, 9, 11, 13, 15, 17, 18, 19, negative.
Unless it starts off like this.
If there are an odd number of negative signs total, like here and here, where there's 1 or 3, then we're going to have a negative number we end up with. If there's an even number of negative signs, including 0, because 0 is even, if there are an even number of negative signs, then the whole thing will be, so if there is 0 or 2 negative signs, it's going to be positive. So you can think of it going through and saying the opposite of this, the opposite of that, flipping back and forth, or you can also just count the total number of negative signs. If there's 1 negative sign, obviously it's negative. If there are 3 negative signs, it'll also be negative. If there are 5, it'll be negative. But if there's an even number, every set of 2, they're going to cancel each other out. Right? If there are 2 negatives here, it becomes positive 5. If we had 2 more negatives, that would still make it positive 5. Making sense so far? Okay. So, when we've got equations that are a little bit more complicated, we can deal with these anyway. Now, one thing I want you to keep in mind when I go to do a couple of examples is what you had pointed out, that the negative sign we could also think of as meaning times -1. Keep that in mind. So here, let's do this example. This is the first example on page 35. And we've got, I'll do it over here, negative parenthesis, -4, close parenthesis, plus, parenthesis, -2, close parenthesis, minus, square bracket, negative, parenthesis, -6, parenthesis, square bracket. That's what we've got here. Now, before we do things in algebra, before we, for example, add things together, or multiply fractions like we saw in one of the problems we went over, we want to make our lives easier. So before we add together -4 and -2 and then subtract -6, let's make our lives a little bit easier. Let's make this cleaner to deal with. What's an easier way to write each of these things?
4 plus -2 minus.
So -4, that's just 4, positive 4. Now you left in plus -2 because this is algebra and we don't like subtraction. So we're going to, instead of, we're going to leave it as plus -2. And what about minus -6?
Plus -6.
We adding or subtracting 6?
Subtracting.
Why are we subtracting 6?
Because it's a negative sign.
How many negative signs do we have? 3.
Oh, that counts as a negative sign.
Yes, because this means plus negative. So we've got 3 negative signs, so it's plus -6, or subtract 6.
What?
Because that's what subtraction means. It means add a negative. So plus negative means that there are now 3 negative signs there, and the whole thing is -6. Does that make some sense?
Mm-hmm.
Okay. Now, this is a lot easier to deal with. 4 plus -2 plus -6 is going to give us what?
-4.
-4. Yes. Yes, -4. Always go and make your life easier first. Now, keep in mind one thing. We have to deal with these negative signs before we can add. Because the negative sign also means what? In addition to meaning the opposite of a number, or on the left side of the number line, what else does the negative sign mean, as has been mentioned a couple times before? What's another way to think of the negative sign? It means
1.
not 1, but
-1.
times -1. And we have to do, in our order of operations, we have to do which first? Multiplication or addition? Yeah, multiplication. This should be familiar to you. PEMDAS. That's going to be really important this year. Quick review of PEMDAS. So in our order of operations, what's the first thing that we do?
Parentheses.
Parentheses. Then exponents. What comes next?
Multiplication.
Okay, the M stands for multiplication. And then the D is division. And then the A is addition. And the S is subtraction. One thing I'll add into this is the last thing we'll talk about today, is that we've already seen that in algebra, addition and subtraction are the same thing. Subtraction is a kind of addition. It means adding a negative. So addition and subtraction, that's actually the same step in PEMDAS. Similarly, we're going to see later that multiplication and division are the same thing in opposite directions. So there are actually 4 steps in PEMDAS. 1 is parentheses, 2 is exponents, 3 is multiplication and division, and 4 is addition and subtraction. Only 4 steps in PEMDAS. You got to remember, multiplication and division are the same thing in different directions, and addition and subtraction, again, are the same thing in different directions.
Yeah.
So those are really the same step. All right, any last questions before I tell you guys the which problems to work on for the homework?
We need the papers.
Yes. Let me give those, and then I'll read off the numbers so that everybody knows them, hears them,
Yes, sir.
all that kind of stuff. All right.
I'm ready. I'm ready.
Promotion. I know some things. I've been around the block a few times. All right. So the following numbers from 7. 4, 5, 6, 7. So I'll write it up here. Problem set 7. Here's the set. 4, 5, ... 7. The ... really only means 6 there. 10, 11, ... 21, 23, 24, 27. That's it. 4, 5, 6, 7, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 23, 24, 27. Goodbye.
Alright.